Hi, my name is Alisa, and thank you so much for taking the time to talk with us today. So let's just jump right into the questions. So the first question is, you do very cool research at Google Brain centering around neural network interpretability. Could you talk a little bit about your work there and why we want neural networks to be interpretable?
So firstly, it's lovely to be here. Thanks for the invitation. And I guess your first question is kind of what do I do research on at Google Brain? So a lot of my research is on how do we train networks to not just be high performance. So to not just have high tested accuracy, but to be things like compact, robust, interpretable. And the way I like thinking about interpretability is it's really to meet our curiosity. If we have a question about how a model behaves, and in particular, how its decision boundary changes, interpretability tools really are to satisfy from different vantage points, from an end user, from a deployment engineer, how do we understand more about model behavior? And I think the most interesting thing is when interpretability tools are not only able to tell us where models align with human intuition, but to also tell us where they don't. That's also really fascinating because often we can learn new things from how models behave. A good concrete example of this is retinopathy models. So retinopathy models, what's been fascinating is that it's been shown that deep neural networks extract features that doctors cannot. So things like, does the scan of the eye tell you the gender, tell you whether the patient smokes? And this is because fundamentally, when we talk about models, we're often talking about a different system for extracting a meaningful representation. So what I find most interesting about interpretability is not just interpretability tools showing you where things align with our judgment, but showing us new or unexpected things about the data that we have around us.
Yeah, that's super interesting. Thank you. During that, you briefly mentioned that you also work on compact models. Could you talk a little bit about the key benefits to compact models as well?
Compactness is interesting. So I first became interested in compactness because I grew up in Africa. So I grew up mainly, well, my parents moved a lot, but I grew up in Mozambique, Lesotho, Swaziland, Kenya, Liberia. And all these communities are very resource constrained. So very different from the environment that perhaps I currently work in, where well, I have unlimited data on my phone. I don't really think about what apps I use. I don't have it to worry about where I charge my phone throughout the day. But also, it means that in communities which are resource constrained, making technology accessible is far more challenging. And so we have two things happening. Firstly, we have this explosion in the size of deep neural networks. So we're getting progressively bigger networks. But at the same time, we have this pressing urgency of making this technology accessible. And that's where compression comes in. So a lot of compression techniques are motivated by really two questions. One is, why do we need such big networks in the first place? If it's possible to compress, and if we can show that most of these weights are redundant to begin with, why can't we just start small? And this is like a very interesting theoretical motivation. And the second is, we simply need to make networks smaller if we want them to be accessible. So how can we do this while also balancing other demands? So it's fascinating because my research is all across these multiple desirable criteria. A lot of my recent work on compression has been on, if we compress, do we give up something else? Do we give up, for example, a degree of robustness? Do we amplify algorithmic bias? And what my recent work has shown with colleagues, it's shown that yes, we do. So one thing which that opens up is a whole new area of research where we ask, okay, so we want to compress. Let's make sure we compress in a way that doesn't unnecessarily amplify other aspects that we don't want, such as amplifying algorithmic bias towards these underrepresented features. So fun times.
That's very interesting. Thank you. Beyond research, you launched a nonprofit called Delta Analytics. Could you talk a little bit about the goal of this nonprofit and your experience building it?
Delta is really, it's a nonprofit which is entirely volunteer driven. So perhaps similar to this community which you have formed. So you have a group of students from MIT and from Harvard, and you're doing something that is you're passionate about. Delta was really, for me, I wanted to connect a lot of the tools that I was using to the communities that I grew up in. So a lot of the motivating question was, why is technology so geographically bound? And now, this was 8 years ago, maybe, I think it's about 8 years ago, which is kind of crazy. But at the time when we started it, it was just 4 of us. And we were actually, at the time, all economists by training, which is a whole other story. So our whole goal at the time was, we're going to do economic modeling for nonprofits. And a few things happened. Firstly, when we first sent out this, we want to help nonprofits, we were just overwhelmed by the amount of nonprofits that kind of wrote back to us, because it was such a severe need in terms of not having there's a huge skill gap. And then the second thing was, it became very clear that economic tools were not sufficient. Like our linear models for a lot of this complex real world data were not modeling the world in a meaningful way. And so both Delta grew. So now it's far beyond myself. And now there's a data program, which is, there's been more than 56 projects done with different nonprofits. And there's also the Teaching Fellows program, which is aimed to actually teach nonprofits how to use data. But also it's now researchers and engineers and economists, and also people who are passionate about using data. But the exciting thing was that in many ways, the mission has stayed the same. It's still completely volunteer driven, and it's still really centered on long-term projects. So we don't do hackathons, we don't do one-off engagements. A lot of our nonprofits come back to us every 6 months. So some nonprofits, we've done a year and a half with them. And so that makes it more sustainable in many ways, because you're not just developing something fancy for a nonprofit and then saying, okay, we're done now.
That's really cool. What was the most surprising thing that you learned when making this nonprofit?
The most surprising thing when making Delta was that a good project requires that you work with, it depends on the nonprofit partner. They have to be super invested, because we actually ask a lot of our nonprofit partners. So we do, like, as I mentioned, it's volunteer driven, so we don't charge anything, but they have to be invested in making, actually leveraging what is produced, and also being able to say no to things, right? We need a nonprofit partner who's able to tell us what exactly they need, and to tell us when to go more simple, where to go more complex. So that's been very critical. You need a good partner, and you need someone who cares. But also the second thing on the volunteer side is, it's kind of fascinating. When people do things at the end of their jobs or in their free time, what you learn is that it actually, community matters a lot. Like, you want to pair people with people that they want to work with, because what I've noticed is that for good volunteer projects, what keeps people invested over long periods of time is working with people that they respect. And so creating this kind of magic in a community, it's actually, I think, something that Delta does really well. Like, a lot of our volunteers have been with us for multiple years, and that comes from pairing people with people that they admire, or that they want to work with, or they feel they have something to learn from. So that's been pretty cool.
Yeah, I guess a follow-up question based off of that is, how has your experience launching your startup differed or informed your launching of the Trustworthy ML Initiative? And have you found that academic communities are different significantly from industry?
Oh, interesting. So I wouldn't call Delta a startup. It feels too, perhaps like Delta has just belonged to so many people at this point, and it doesn't have one of those missions like take over the world. We're a very small community, but I have worked at a startup. So I worked at a startup before Brain, and Trustworthy ML Initiative is also a very important initiative. It is aimed more at academia. So I think that Trustworthy ML Initiative, the goal is very different. The goal is to unify these aspects or fields of study that have been treated very separately. So I mentioned how I'm doing this work on compression and showing how it ties to algorithmic fairness. This is actually new. I mean, often people treat fairness as this one area and compression as this one area. And in compression, you only care about the number of weights that you can remove. And in fairness, you treat it as you have all these labels. But we don't really talk about how these properties interact, or how there are these threads between all these fields. So Trustworthy ML Initiative is really this goal. Let's showcase speakers from each of these subfields and start making these connections. Because what's fascinating about research is that a lot of brilliant research, a lot of research that opens up or kind of does a stepwise function in progress is research which connects things in ways that have not been connected before. And I think that the tricky part about specialization science, and this is prevalent in many different places, is that it tends to deter or disincentivize cross-pollination of ideas. People are kind of in their lane, they're specializing in the one thing that they do well. And Trustworthy ML is really an effort to shake that up, is to say we need to create spaces where we do this type of cross-disciplinary research, because that's the type of spaces where you see these connections which really do make strides in how we treat ideas and create these more holistic perspectives. I think that your first question was, how does that differ from a startup? I mean, I can talk about the difference between working at a startup and working in an academic lab, although it's an industry, if that's interesting. That might be a better comparison.
That sounds interesting. If you could talk about
Okay.
that, we'd appreciate it.
You've got me, Alisa. I want to make it. Okay, that sounds good. So I think there, and maybe this is fascinating from the perspective of people choosing different routes. So when I worked at a startup, I worked at a fantastic startup called Udemy, which I loved for many reasons. And it's a marketplace of courses. And there, the difference is I was working as a machine learning engineer, and I was deploying some of our first recommendation algorithms. So right off the bat, it's very exciting in terms of your impact. So you get to do, at a smaller company, you get to do many of the firsts. And it also means that you quickly are able to grasp a lot of the key principles of not just iterating an idea, but deploying it, which is its own set of skills. The second thing is that deployment of machine learning focuses on simplicity. So it forces you to justify every additional ounce of complexity that you add to an idea. And I think that's a good practice in general as you approach any problem, is to focus firstly on what is the minimal viable solution for something, but then to iterate from there and to say, well, if I add this amount of complexity, does it justify, does the return justify it? What I would say the tricky part is that often you aren't able to pursue any one idea to completion. So the motto is often, this is good enough, let's try this. And then often good enough becomes the algorithm. And so there is this interesting tension where you get to do a lot and see a lot of impact. And in particular, you get great feedback loops, because when you deploy an algorithm, what you see immediately is how much money you've made, which is very satisfying, because in research, often we throw a cherished idea into the world and we don't know for years whether we've made an impact. And so it is really fun to be able to say, wow, my algorithm made bank. I mean, that's got its own sense of accomplishment. With research in an industry lab, what I would say is you get this very exciting sense of both community, because you're working with a lot of scholars. It's a very dense concentration of talent. And so you feel like in a startup, often you end up becoming the expert very early in your career, and that has its own predicament. Whereas when you're in an industry research lab or an academic research lab, there's no such danger of that, because even when you're at the top of your specialization, everyone has their own specialization. And so you're constantly thinking about other people's perspectives. The second thing I would say is that it also does have this wonderful cycle where you can follow things to completion. So if you have an idea, you can fully explore it and you can think about it and propose new methods. And there is something also beautiful about sometimes being able to play in a sandbox without having to worry about the messiness of deployment, because that can take a long time. And so researchers are quite spoiled in the sense that often they can abstract away parts of the pipeline in order to really focus on something that generalizes broadly for one part of the pipeline. So that's a few thoughts there, but that might be helpful as people think about their choices and their career choices down the line.
Yeah, thank you so much for sharing those tips. Just to jump back a little, you previously mentioned some of the barriers that you thought to entry to ML. And so if you had like a magic wand that could do absolutely anything, what would you use it to change to help with accessibility for machine learning?
I think that the biggest barrier to accessibility is geographic concentration of talent. And so in many ways, this is a problem which comes from both how we identify talent as well as how we nurture talent. So right now, if you think about ML centers, I'm sure only a handful of cities come to mind. And that's wrong because the world is big and problems are not, they're not correlated with these few cities, and in fact, problems exist everywhere. So one of the biggest issues that we have to address as a community is how do we select and how do we train and how do we support talent as it grows across the world? And that means a few things. It means that I challenge my colleagues all the time to rethink their collaborations, because I think that researchers and practitioners, as humans, we tend to weight most heavily what's immediately in front of us. And so there's always a danger that you have your existing collaborations, you have your existing network, and you just repeatedly default to that. And so forming collaborations and rethinking how research is done and how collaborations are done is very important. For example, there's all these independent research collaboratives that are emerging, such as Masakani, such as MLC, that are rethinking how do we create research hubs where people can come in as independent researchers, maybe they're not even affiliated with an institution, and be able to engage and be able to receive mentorship. This is the second problem, which is frankly, there's still too few specialists in these areas. So the truth is, it shouldn't just be at places like Google Brain or places like MIT or places like Harvard, where you can have the type of apprenticeship that we normally think of in terms of becoming a domain expert in this area. We have to rethink how we create mentorship patterns, and we have to connect many of the students who are coming for the first time from countries in Africa or Latin America to conferences like NeurIPS, use that as a starting point for longer term collaborations. And then of course, the other thing is to reward research which is done in different areas. We have, if you look at what is published at NeurIPS, at ICML, there's a huge gap right now between what researchers talk about and care about and what the implications of our algorithms on the world as large. We have to foster and support research that is done more on how our algorithms are impacting the world, and to reward work that does that. And I still see too little of that. I still see us favoring too much, although I love my physicist colleagues who write lovely and very detailed proofs, I think that there's also room for us to support people discussing the implications of these algorithms and how it impacts, for example, low resource languages, or how we do better at fitting models to low resource languages. So I'm going to stop there because I can feel like this could be a whole conversation in itself.
So it sounds like you've also been you have many opinions about the world and you've sort of been all over the place. And you mentioned you grew up in Africa and then you did economics. So I was wondering if you could talk a little bit about your own trajectory into getting interested in machine learning.
So my career has really been driven by curiosity. So I started my career doing economics mainly because I had grown up, most of my childhood was in Mozambique, and in Mozambique, a lot of the problems that I saw, the most technical people that I saw addressing them were economists. So I was very determined I was going to do macroeconomics for the World Bank. And that was the toolkit that I thought was really interesting. To some degree, that was the path I followed. Even after I moved to San Francisco, I was working, doing economic consulting with PhDs in Berkeley. And it was only when I started Delta and really working with those nonprofits and seeing where economic tooling fell off a cliff, so to speak. Although there's still very interesting properties and frameworks to economists. So I'm not, I think in many ways, I still carry a lot of my economist training with me. But it was there that I became interested in firstly, different types of tooling, but also as soon as I realized that, I became very interested in controlling the process end to end. So particularly with when we talk about large scale data sets and when we talk about complex models, I really urge people early in their career and thinking about how they want to specialize to have the experience of being able to control the problem end to end, meaning to process the data, to work on being a strong engineer, to work on then crafting your algorithm or how you model data and the assumptions that you impose then. And that's more in your theory bucket, your math bucket, and then also to think about the implications of deployment. And the reason being is that if you control something end to end, your iteration speed and your ability to navigate a question and to propose your own hypotheses, it automatically opens up a lot of doors. And so that's what I would define as the brute force stages of my career. So I joined Udemy first as an analyst, and then I transferred to our engineering team, really thanks to the directors who really believed in me. And there I really focused on this whole end-to-end process. And then I started teaching, and I went to moved to Kenya, and I was teaching there. And then I joined Brain as a researcher. And research for me at that point was I'd done applied machine learning, and I wanted to understand how research was different or whether I would enjoy it. And I do really enjoy it. And so now I've been at Brain for close to 4 years. So that's been also an exciting chapter.
That sounds so exciting. I guess finally, do you have any advice for younger students interested in the field, possibly such as like whether they should start on the theory side or the application side or stuff like that?
My biggest suggestion is to start with the why, like why are you interested? And what I mean by that is that I often find the hardest part of this process is remembering for yourself what you bring to the table and also why you're there, because it can feel really long, particularly if you're self-taught as I was. It can feel very lonely and it can feel really disheartening at times, just going through all the cycles of learning and getting to the different stages of the learning process. But when I say remember why, I also mean focus how you learn on something that you're passionate about, and particularly something that speaks to you and your community. Because another mistake I see in students who start this journey is that by focusing on a million different things and a million different resources, you end up feeling overwhelmed. Whereas if you focus on how you want to help and what is driving you and choose a project that is important to you and your community, not only do you have concrete goals as you make progress on that problem, but also you automatically become a teacher because you are now working on a problem which not everyone works on. You're not working on the Titanic data set in Kaggle. You are working on something which is important to you. So for me, a lot of what drove me was working on Delta projects and working on projects like Rainforest Connection, and we were detecting whether chainsaw deforestation was happening. But it really was an amazing project to collaborate on because I felt like it was something which was very close to my heart, which I was learning a lot from, but also was immediately having a huge impact. So I truly recommend for anyone who starts out, remember what you bring to the table and center how you work around what you bring to the table. Because there will be many rooms that you go into where you will be the first person in that room who is like you. And if you are constantly overfitting to the rubric that you think is present in that room, you end up losing sight of the fact that you being there is for a reason, and you yourself are bringing many different attributes that other people don't have, and other rooms that other people don't have access to. So yes, think about why you care and start there.
Great. We don't want to keep you from your research, so thank you so much for your advice and your time, and we hope you have a wonderful day.
It was really lovely. Thank you, Lisa. That was an excellent interview.